Hello and welcome to another exciting chemistry session. This is your host, Mr. Mwansa. So for today, we're going to start a new series, and this series will be titled "Language of Chemistry." This series will be titled "Language of Chemistry." So under language of chemistry, we'll get to know the familiar terms, the common terms, the common language that is used in chemistry, as they talk about things such as an element. We've talked about an element in the previous series under atomic structure. Uh, we can now talk about a compound. What is the molecule? What are radicals? How do we write a chemical formula? And so on and so forth. So join me in this series and let us get to learn the language of chemistry. So we'll start by looking at description of what we call a compound. Description of a compound. So before we talk about a compound, there is need for us to understand where the same compound is coming from. Where is a compound coming from? So a compound comes from what we call an element. So there is need for us to define what an element is. So an element is just a pure substance that is made up of one kind of an atom. We talked about this under atomic structure. So an element is just made up of one kind of an atom, and this particular element cannot be split into two or more by any physical or chemical means. So you can try any physical, any chemical means, you cannot split this particular element. Now, what is the composition of an element? So if we're looking at this, I think in using a diagrammatic representation. So if this is an element, this is an element using a diagrammatic representation. We are saying an element is composed of atoms. So an element is made up of atoms. So these atoms should be of the same kind. These atoms should be of the same kind. So we find atoms that is in the inside of an element. So that is just the composition of an element. Now, how does a compound come in? How does a compound come in? How does a compound come in? So let's look at our notes. Let's refer to our notes. So once we have an element, like we have here, we'll look at hydrogen. So hydrogen element is made up of hydrogen atoms. Then oxygen element is made up of oxygen atoms. Copper element is made up of copper atoms. Now we can talk about all these characteristics of an element and characteristics of a compound, but for now our interest is how do we formulate a compound? How do we formulate a compound? So let's just look at the page down below. So what really is a compound? What really is a compound? So a compound is a substance formed when atoms of different elements, chemically combine. When atoms of different elements chemically combine, then we're going to have what we call a compound. So we have examples right here. Water is an example of a compound, glucose is an example of a compound, carbon dioxide is a compound, ammonia is a compound. If you look at their chemical formulas, these are their chemical formulas. Now my interest is the composition, what is found in the inside of these particular compounds. So in water, as we are aware, we know that in water we have hydrogen and oxygen combining in a certain proportion. In glucose, we have carbon, we have hydrogen, and we have oxygen. In copper 2 oxide, we have copper and oxygen. In ammonia, we have nitrogen and hydrogen. So what happens is different elements come together and they form what we call a compound. So atoms of the same kind come together to form what we call an element. So that is how an element is formed. That is, atoms of the same kind come together. But when elements now, different elements, so we can say element 1, different elements. Element 1 combines, so it's a chemical combination, combines with another element, combines with another element, combines with, we can say, element 2. So when different elements combine, remember we said an atom is the smallest particle of an element that takes part in a chemical reaction. So it's not these elements that are reacting, but the atoms in the inside of them, because an atom is what reacts. An atom is what takes part in a chemical reaction. So the atoms inside there will combine with atoms of another element, and together they form what we call a compound. Together they form what we call a compound. So atoms of the same element form, atoms of the same kind form an element. Then different elements come together and form what we call a compound. So that is just a simple breakdown of where a compound comes from. A simple breakdown of where a compound comes from. Let's refer back to the notes. So those are some of the examples of compounds and their composition. So if you look at the diagrammatic representation of water, so in water you have oxygen. We have oxygen. Let me try to magnify what is there. So to magnify this, in water we have oxygen at the center and then surrounded by hydrogen. So there is hydrogen there, then oxygen. So hydrogen is smaller than oxygen in terms of the atomic size. So those are different elements combining. So hydrogen and oxygen, those are different elements that come together and then they form what we call a compound. So this is a compound. This is a compound which is formed after hydrogen. So in chemical equations we say hydrogen plus oxygen combine and then they form H2O. H2O. So we haven't yet looked at chemical equations, but this is how we write the chemical equation. So that this is a compound, and these are different elements coming together. So now that we understand what a compound is, now that we understand what a compound is, it is very important to also know its characteristic or its characteristics. What are the characteristics of a compound? So a compound cannot be separated by physical means. Remember, this is a chemical combination. You're combining two different elements chemically. So you cannot use any physical mean to separate them, but you can use any chemical mean to separate. Energy is given out. Whenever you're forming a compound, definitely energy is given out. The properties of a compound are different from those of an element. So what does this statement mean? So if you look at hydrogen combining with oxygen to give you water, these are two different components. The characteristics of water are not anywhere near the characteristics of hydrogen and oxygen. So that is the meaning of this. When you look at the physical properties of water and the physical properties of hydrogen and oxygen, they are totally different. So it's not like when these two combine, then their physical properties will also accompany them as they form a compound. No. So a compound is totally different to come up with its own physical characteristics, which are totally different from that of the reactants or the elements that are involved. Then a compound always comes with a fixed composition. So what do they mean by fixed composition? So water is always H2O. That is the meaning of fixed composition. They always combine in that ratio. 2 hydrogens, 1 oxygen. The moment you change, you say H2O2, even the name changes. So this is water, as we are aware. This is water, but this becomes peroxide. This becomes peroxide. So the moment you change the composition, then you change the name of the compound. So the proportions are always fixed. They combine in a fixed proportion, and it will never change. If you look at glucose, you always get C6H12O6. That is glucose. The moment you decide to tamper with these proportions, then you're changing the name of the compound. So those are some of the characteristics of a compound. So what is a compound? A compound is a chemical substance formed when two or more different elements chemically combine. That is what we call a compound. Now, this compound, this formation of a compound, this formation of a compound comes with certain rules. And this is what we are going to focus on at this particular time. We're going to look at how to write the chemical formula of a compound. How to write a chemical formula of a compound. So where is this H2O coming from? Where is the CO2 coming from? Where is the magnesium chloride coming from? Where is the sodium sulfide coming from? So we have all these questions. Where are these formulas coming from? So this is what we're going to focus on at this particular point. So to write a chemical formula, always remember the atomic symbol. Always remember the atomic symbol. So these are some of the things that we need to pay attention to. So if you don't understand the atomic symbol, you can go back to the atomic structure. We have a series on atomic structure that you can watch, and then you'll get the concept of this atomic symbol. And then we have what we call a valency number. So a valency number is just a combining power of an element. So when you go to the periodic table, you find these numbers. So that is the valency number: group 1, group 2, group 3, group 4, group 5, group 6, group 7, and their respective valency numbers. So what happens is, for you to come up with these particular chemical formulas, they're going to give you a name of a compound. A name of a compound. For example, allow me to use, say, hydrogen, 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 hydrogen oxide. So this is a name. Say this is the name of the compound, hydrogen oxide. And then you're wondering, how do you translate this hydrogen oxide into these formulas? How do you translate this hydrogen oxide into a chemical formula? So a chemical formula involves chemical symbols. Chemical formula involve chemical symbols. So the first rule is identify the elements present in a given compound. So you're given this compound. So when you look at this compound, what are you able to see? What elements are you able to see? So hydrogen oxide means I have hydrogen. There is hydrogen mentioned, and there is oxygen, which is coming from oxide. So once you're able to identify those particular elements from a given compound, what about their atomic symbols? So what I have just written here are their atomic symbols. So if you know their atomic symbols, well and good. What about their valency numbers? What about their valency numbers? Do you know the valency numbers? So what is the valency number? What is the valency number of hydrogen? So the emphasis is write the valency number on the right side of an element as a superscript. So the valence number of hydrogen is 1. Then what is the valence number of oxygen? So when you go to the periodic table, you find that the valence number of oxygen is 2. So from there, the fourth step states that we have to interchange the valence numbers to make them subscripts. So by interchanging, it means this one comes there, then this one goes there. So this becomes H2O1, where we know that O1 is the same as O. So this becomes H2O, which is the famous water. So hydrogen oxide is the famous water. So this is how we translate these rules into helping us to write the chemical formula. So we can look at the following examples under the writing of chemical formulas that are down below the book. So the first example I have is aluminium oxide. First example I have is aluminium oxide. So aluminium oxide, you ask yourself, what is found in aluminium oxide? So in aluminium oxide, you have aluminium and you have oxygen. That is the first step. The second step is what are their valence numbers? The first one is to identify, the second one is to write the chemical symbols, the third one is what are their valence numbers. So the valence number of aluminium is 3 when you go to the periodic table. Then the valence number of oxygen is 2. And what do you do from there? You interchange. So it becomes aluminium 2, then O3. So this is what we call aluminium oxide. Aluminium oxide. We have magnesium chloride. It's the same thing. So it's just a matter of identifying what is present. So what is present in magnesium chloride? So in magnesium chloride, you have magnesium, which is Mg, capital M, small g. And you have chlorine. What is the valence number of magnesium? So the valence number of magnesium, according to the periodic table, is 2. The valence number of chlorine is 1. Then what do? Interchange. So it becomes Mg1, then Cl2. So Mg1 is the same as Mg. Mg1 is the same as Mg. Cl2. So this is what we call magnesium chloride. So when you're writing these chemical formulas, the emphasis is on the atomic symbols. Ensure that you copy the atomic symbols the way they are. If it's a capital letter, a small letter, just follow them the way they are represented on the periodic table. Then when you write the chemical compound, don't leave space in between. Do not leave space in between. I have seen where some people write magnesium, then they leave space and say chloride. So this is wrong. So they're supposed to be, it becomes 1. So it's magnesium chloride, like that. Magnesium chloride. So those are some of the basic things that we need to pay attention to. There are a lot of questions that we can answer on these chemical formulas. They can give us all sorts of chemical formulas to write. What is important is understanding the periodic table. I can say, right, for sodium oxide, right, for potassium sulfide, right, for calcium nitride, right, for which one can I pick? Barium fluoride, barium fluoride. So those are some of the things that we can be asked to write their formulas. So what is important is know the periodic table from the inside out. So I said group 1, group 2, know the valence numbers. So group 1, you have group 1 there, you have group 2, then you have this long stretch here on the periodic table, then you have group 3, group 4, group 5, group 6, group 7 and 8. Group 7 and 8. So this is group 3. So always be interactive with the periodic table. So this is 4, this is 5, this is 6, 7 there. So those are groups. Then we have group O, which is group 8. So the valence numbers, just to remind you, so the valence number here is 1, the valence number is 2, the valence number is 3, 4, then 3, 2, 1. So whenever we are combining, so what is sodium oxide? So sodium oxide, you have sodium like that, then you have oxygen. what is the valence number of sodium? So sodium, the valence number is 1. Oxygen, the valence number is 2. When you interchange, this results into sodium 2, then O1. So O1 is the same as O. So this is the same as sodium 2, then O. What about potassium sulfide? So you can pause the video and then try it and see if you're able to get the correct answer. So what is found in potassium sulfide? So in potassium sulfide, you have potassium and sulfur. So sulfide, that is just sulfur. So what is potassium? Potassium is K, capital K. Sulfide is capital S. The valence number there is 1. The valence number here is 2. When we interchange, what do we get? So we get K2S. What about calcium nitride? So calcium nitride, you have calcium. Then what is nitride? Nitride is coming from nitrogen. So valence number of calcium is 2. Valence number of nitrogen is 3. When you interchange, this gives you calcium 3, then capital N, which is nitrogen 2. So ensure that you copy the elements the way they are on the periodic table. Barium fluoride. So barium is capital B, small a. Then fluoride is capital F. What is the valence number of barium? Is 2. The valence number of fluorine is 1. When you interchange, you get barium F2. So that is how we come up with these formulas. Then there are situations where you have, for example, sodium chloride, sodium chloride. So sodium chloride, you have sodium Na, then chlorine, which is CCl. The valence number of sodium is 1, and the valence number of chlorine is 1. So in a situation where you have valence numbers that are equal, you just cancel them out. There is no need for you to interchange. Then you're going to have sodium chloride like that. So in a situation where you find yourself having the same valence number, feel free to cancel them out. You have calcium oxide. So the valence number of calcium is 2. The valence number of oxygen is 2. So if they're equal, cancel them out. Then you have calcium oxide. So this is where we come to the end of this particular session of our first series under language of chemistry. So we'll continue looking at the writing of chemical formulas. Now in the next series, we'll incorporate the use of what we call radicals. Look at how do we write a chemical formula when we have radicals. So thank you. If you have questions, as usual, feel free to put them in the comment section, and then we will respond to those questions. Bye-bye.